the Earth rotates. Is that true? Really? Well, let's take a look at the different arguments we might have. First of all, what are we going to discuss? Well, first of all, the observations. What do we observe? What do we see? A very good basis for scientific arguments. Ptolemy, Copernicus and Tycho had about the same observations but came to different conclusions, 3 different models. And we also have Kepler, Newton and Einstein coming a bit later, and these are also very important for our understanding of the solar system and the universe. We want to weigh their arguments, and of course we also want to take a look at what the Bible says about it. First of all, we have our observations on the sun. From east to west we see the sun rising in the east and setting in the west. Well, not always exactly. At the start of the autumn and the start of spring we have that it does rise in the east and sets in the west. That's what we see. And we have the length of day is the same as the length of the night. But it's not always so, because we have seasons, and in the summer here at our latitude we have the sun rising of about northeast and setting northwest, and in the winter it's vice versa with southwest and southeast. So the seasons are important, and the latitude is also important. If you go to the equator, the days are always the same length, very boring. If you go to the poles, then the days can be different in their length very much. You might have a day where you don't see the sun setting, or you don't see him rising in winter time. Moon, stars and planets, well, in the south they follow the path of the sun about. You have the moon and you have the stars and also the planets, and the stars here you see is Orion, and it goes in the south following the path of the sun about. Moon cycle, well, we're not paying much attention to the moon cycle in this video because it's not important for our arguments. The day of a star is about 4 minutes shorter than the solar day. And you have difference between south and north. We come back to that. Planets are roaming stars. They move between the fixed stars and they don't have always the same position. For instance, Venus, part of the year it's a morning star, another part of the year it's an evening star, and a part of the year you don't see it at all. And Mars, here you see the Mars having a going backwards for a moment and then going forwards again against the fixed stars, the background of the stars. If you take a look at the starry sky south, then you see the Orion, for instance, very clearly in winter time, and this Orion with the different stars, Sirius is a very bright one, is seen, and it goes like this from east to west. But in the north sky it's different. Then it goes like this. You have here W, stretch W, that's Cassiopeia, and here you have the small dipper, the little dipper, and big dipper is higher up, and it orbits, it turns around the polar star. The model of Ptolemy explains it like this. You have the Earth in the center and everything orbits around the Earth. The sun rotates daily as the stars, but the sun also spirals up and down to explain the seasons. And that's why the star day is a bit shorter, because they don't orbit. They don't spiral up and down. And the planets, these have epicycles to explain these strange movement of the planets. It's a bit strange, these epicycles, because they orbit around a point, and that point, which is nothing physically, orbits around the Earth. So mathematically it's quite okay, but physically, well, there's a bit of a problem. Copernicus saw this problem and he wanted to make a more elegant model. Setting the sun in the center is a better model, he thought. And you have also the stars just fixed, they don't move at all, but the Earth rotates daily around its axis and moves around the Sun, orbits the Sun like the planets in a year. Well, the planets have a different year, but the Earth, our year, is one orbit of the Earth around the Sun. Is it more elegant? Yes, it looks more elegant, though there are a few problems still to be solved. What are arguments of the geocentric model, thinking Earth is fixed in the center? Well, you don't notice speed. For instance, if you take a look at a stone, you throw a stone from a tower, and the Earth rotates, and it goes with a high speed. Why doesn't the stone fall away from the tower or fall against the tower? Why does it go straight down? And those birds, they don't seem to notice the speed of the Earth as well. They fly in any direction without, well, maybe the wind is important, but that can be from any direction. So these problems are there. And you always feel speed if you go with a certain speed, on horseback for instance. And the star parallax was also not observed. And what is a star parallax? Well, if the Earth orbits the Sun, then it has a different position relative to the fixed stars in different parts of the year. And why don't we notice that? It wasn't noticed at that moment. Star parallax. Well, what is parallax? Well, what you see, the moon hardly moving, the mountains in the distance move, and the trees closer by move even faster. So the further away, the less movement you notice. That's parallax. Tycho Brahe made a different model. Almost at the end of the 16th century, he has this model of the Earth in the center, fixed, standing still, and the Sun rotating daily, and of course also spiraling up and down yearly, and the stars also rotating daily, the whole of the universe rotating around the Earth. But the planets orbit the Sun. Then you don't have these epicycles anymore. The planets have a center they orbit around. So it's a more elegant model in a certain way. And why is it important to have this model? Well, in 1609, Galileo uses a telescope and he sees things. He sees this. With this telescope, by the way, a Dutch invention, he sees this. Different phases of Venus. Venus being closer by, but only a crescent, and further away, almost a ball. How do you explain this? Well, if we are here and we look towards Venus and the Sun, Venus orbits the Sun, then it can be explained very neatly. Here you see a crescent like this one, and further away you see almost a ball. But then Venus is almost behind the Sun. You never see a full ball because then you don't see Venus because it's behind the Sun anyway. That can be explained with the model of Tycho Brahe and also with the model of Copernicus, and in the conclusion in the 17th century, about halfway, by Riccioli, a very intelligent man, a learned man, but also a cardinal at the Vatican, and he wrote this book with this nice title page. And Ptolemy is thrown away, it's out, you can't use it, it's not a good model, it isn't coherent with all the observations, but we have still the option of Tycho, because Copernicus also has kind of epicycles to explain the movements of the planets. It doesn't work very well because of the circles. The Greek had this wonderful reason for everything must move in circles and also balls, because that's the divine way. It's the ideal. Well, that's not the way the Lord always creates along the lines we think is logical. So Copernicus also uses epicycles, and that's why Tycho seems to be better. Also because of the moons orbiting Jupiter, as you can see this also in this picture. It There are different things to be seen, also the phases of Venus here. So the speed is still not noticed, not explained. Why don't we notice speed? And we don't have an observation of star parallax still. But then we have Kepler and Newton. Kepler uses the calculations and the observations of Tycho Brahe, very detailed observations, and he can use them. And he starts doing his calculations, and he comes to the conclusion that planets orbit in an ellipse, in an elliptic orbit. This is a bit overdone. The Sun is almost in the center, but not quite. So it's an ellipse, and it's different for different planets. And that's a breakthrough, because he capitulates for the observations. It's not a divine circle, it's just an ellipse. Well, a very nice one. And it's also very good design, but it's not a circle. And you have the law of gravity of Newton, and also the law of inertia, that we have a big ball attracting a smaller one more than vice versa. So this one will move this way more easily than, and if you have the orbit, then it's logical to have the Sun, the bigger one in the center. So he can explain the whole solar system by these two laws. In such a way, take a look at how speed can be explained. And we have speed on horseback. Well, we all notice speed then. You feel the wind in your face if you go fast, galloping. And of course, it's going up and down as well. And in a horse and carriage, well, you will also notice speed. That was in the 16th and 17th century. So such a logical experience, everyday experience. Speed, you will notice speed. But in an airplane, we nowadays know that's not the case. If I fly to India, leaving the Earth is, well, then the speed goes up and up and up and up, and I will feel it. I'm pushed back in my chair. And by landing the airplane, you also notice you have to brace yourself. But flying the highest speed in the air at this high altitude, and you have a high speed of about 900 kilometers per hour, you won't notice anything. And by the way, 900 kilometers per hour, that's about 250 meters per second. Well, stand in the front of the plane and throw up a ball, staying in the air about a second. The ball travels in that second 250 meters, but you don't find it in the back of the plane. It lands neatly in your hand. And that's the law of inertia. If you don't change speed, then you don't notice it. And you have the same speed as the airplane. That's what we also have in the rotation in the Earth. We have the same speed. So most of the speed isn't noticed. But orbiting the Sun is also very high speed, because it's about 150 million kilometers we are away from the Sun. So in orbiting the Sun is about 1 billion kilometers. And it is a speed of about 108,000 kilometers per hour if you do the calculation right. That's a very high speed, but we don't notice it. That's the wonder of creation, that we don't always notice the wonderful things the Lord has put into creation. And this is a wonderful thing to think about, how great thou art, Lord Creator. But if you have the Sun orbiting the Earth, then this 1 billion kilometers is covered every day. That's very high speed. So the arguments of the heliocentrism is the speed problem is explained. First Kepler with his 3 laws and Newton building on it. And his elliptic orbits also make the model much nicer and much more elegant without these epicycles. Gravity, inertia also explain the things. Parallax is observed, and we have the Coriolis effect. First, the parallax. Bessel has a better telescope using it in 1838, and he notices this particular parallax. It's a very small part of the sky we take a look at here, and we see the stars, 6 different stars, and 3 of them move a bit. A moves a bit, B moves a bit more, and D moves even more. The other 3 stay at the same spot because these are further away. That's what parallax is. But the Coriolis effect is where we do notice speed, because there are different velocities in orbiting the Earth. At the equator is the highest, and at the poles it's almost nothing. And these different velocities per latitude see to it that these have an effect on the winds. The northern hemisphere, the wind deviates to the right, and in the southern hemisphere to the left. That's what we can see. If we take a look at hurricanes or tornadoes or whatever, we can notice this. And it has to do with the rotation of the Earth. And that's what the Met Office, of course, has to deal with. It uses this effect. Because if we don't take it into our models, then we can't predict the weather in the right way. Newton explains a lot, that's what we said. But not everything. Neptune was found by an aberration in the orbit of Uranus. First the calculation, and then trying to find it, and with our telescope we found Neptune. But we also have an aberration in the orbit of Mercury. And so we already named the planet to be found there Vulcan, because being so close to the Sun. We never found this planet because it's not there. But Einstein explains it with his relativity theory. Well, don't think relativity theory means that everything is relative. No, that's not true. But it does mean that clocks can run in a different speed. And if we take that into account, we could explain that the age of the universe seems to be so much more, the stars, farthest stars, being maybe 14 billion years old, almost, and the Earth only 6,000. That has to do with the relativity theory, maybe. Well, of course we don't know exactly, because we can't look into what the creation really is. We still are curious to know things, but we can't know everything yet. But maybe it explains the age of the universe being so high, and the Earth being not so very old, only about 6,000 years. What does the Bible say about it? Well, of course, you have sunrise and sunset in the Bible as well, as we also use in our everyday language. We do use it, because the Bible uses the language of the observer. And that's why we need to take a good look at what is meant. For instance, this one. The world is firmly established, it shall not be moved. Doesn't mean that the Earth doesn't rotate. No, it doesn't move out of its position, just as I will not be moved out of my position relative to the Lord. That doesn't mean that I don't walk or don't cycle, don't have movements, but I'm not moved out of my position. The Earth is shaken exceedingly. That's what can happen. And it is a good example of what happened in this particular example. Sun stands still. Joshua commands the sun and the moon to stand still. Not only the sun, also the moon. If he wants to prolong the day in an Earth-centered universe, he only needs to command the sun. But he commands the sun and the moon together. And that fits very well with a rotating Earth. And it also fits very well that these large stones falling on these people. It was a very special event. It wasn't heard before that moment that the Lord heard such a mighty in such a mighty way. What one man asked, very special. And the Sandal of Hezekiah is just like it. The Lord can use his might to hold the earth in his hand and to keep it still for a moment. He can do that. He is mighty. It's the mighty Lord. And by the way, just take a look at creation. The light was created first. The sun only on the fourth day. The sun isn't the light of the Lord. He isn't God. But the light, God is light. That's what the first thing is we find in the first letter of John, the Apostle John. First speaks about the light. God is light. In him is no darkness. And light and the rotating earth, that explains evening and morning is a day very well. The light is at the center, not the earth itself. So God is great. He is a great God. The conclusion is the earth does rotate and it orbits. And it's in a wonderful way designed. The whole solar system is beautifully designed. With Jupiter being our guardian, catching away some of the debris that can maybe harm the earth. And there are other things that is beautiful design. But maybe we are still at the center of the universe. There are reasons to suppose this is true, just like I spoke about the age of the universe a moment ago. We're not going into it this moment, but I conclude the Lord is mighty, the Lord is the creator, and we praise him for his wonderful design. Amen.